Linear inequalities and interval notation. We're solving some linear inequalities, solved very similar to solving an equation, but the key is going to be we need to write our answers in interval notation. So just some examples of interval notation. If I want x less than 5, there's my inequality solution. In interval notation, this would be negative infinity to 5 with a parenthesis. This is the way we're writing those solutions. Everything in interval notation. Now, sometimes it's brand new to you doing the interval notation, sometimes not. Making this transition, a graph can help. So an old number line graph, old style number line graph, if x is less than 5, you may remember doing an open circle and coming back to the left. Well, that open circle can also be represented by a parenthesis, and some of you may have done that, may not, but you should remember one of those two. So this is just representing our interval notation. I've got all the values from negative infinity back here up to 5. Parenthesis means I'm not including the 5. So the inequality symbols, less than, greater than, and then we had the equal to part. So if I had x greater than or equal to 2, let's give us an equal to example here. The interval notation would be bracket 2, comma, infinity. So all the values larger than 2. Okay? On a number line graph, if I put a 2 there, you may remember in the past doing a closed circle because of the equal to. Going to the right, greater than's going to the right. Well, a closed circle is also represented by a bracket and going to the right. So that bracket's what's giving us that interval notation. So if we see the equal to, we're going to have the bracket. If we don't see the equal to, parenthesis, and then we're either coming from negative infinity up to 5 or up to the value or 2 going forward. I'm not going to require you to draw the graphs on every problem, but I think the graphs give you a good visual. So if you struggle going from here to here, if this is new or if it's a struggle for you, well, let's draw the graph and then make the transition from your graph to your interval notation. If you're used to the open circle and closed, what we want to do is just kind of get used to using the parenthesis and the bracket on the graph. So the graphs can definitely help, even if you're kind of visualizing them in your mind versus drawing them out. All right, now let's look at some solving processes. As far as solving these linear inequalities, the nice thing is the solving process is not going to be new to us. We've seen our basic two-step equation. 3x minus 2 is less than 7. Make something up there. Right? The only thing different now is I'm seeing an inequality symbol versus an equal sign. I'm going to treat it like an equal sign, which means if this is equals and I want x alone, I'm going to have to move the 2 over and divide by 3. So if I add 2, 3x less than 9, right? And then my last step, divide by 3, x less than 3. So I'm ending up with an answer of like x less than 3 instead of x equals 3. So the nice thing is very similar to just solving your equations in the past. Our answers, our solutions, final solutions, are going to be in the interval notation. This interval notation would be negative infinity to 3. All values less than 3, negative infinity up to 3. Again, if a number line helps you, do a quick number line graph. There's 3. Parenthesis, less than, it's going that way. It's pointing that way. That kind of gives you that to make that transition. But this is how we're going to write our solutions. We then went from something like this to seeing equations where we had variables on both sides. So something like a 9x plus 5 is greater than or equal to 4x minus 8. Where we saw that variable sitting on both sides. So this was a little more than the two-step equation, but still something that wasn't unfamiliar. I'm going to get my x's together, or my variable terms together. Subtract my 4x. Now I've got 5x plus 5 greater than or equal to negative 8. Now we're back to that two-step equation kind of looking like this one. Subtract my 5x greater than or equal to negative 13. And then my last step, divide by 5. So I'm going to have x greater than or equal to negative 13/5. I'm not worried about if a fraction shows up. The key is I've still got to get my interval notation. The interval notation for this, bracket, because I see the equal to. So I have negative 13/5, bracket on that, comma infinity. And we're going from negative 13/5 to infinity versus negative infinity up to that. Again, think of the graph. Here's negative 13/5, bracket, it says greater than, look which way it's pointing. The right, going to the right. So I'm going negative 13/5 up to infinity. Bracket because of that equal to. So here's the transition we're making from here to interval notation. Notice the solving process, not any different. Let's get a couple variations here that we do run into. Sometimes our variable term will end up on, say, the right side. We've seen the variable on the right side many times before in solving. Whether or not we like it there, we've seen it there. So let's look at one with the variable on the right side. Let's go with 5 less than or equal to 2x plus 9. Right? Sitting on that right side, we've seen it before. I know I'm going to subtract that 9 over, then I'll divide the 2 out. I'm going to go through that process. Negative 4 is less than or equal to 2x. Subtract the 9, now divide by the 2. So I'm going to have negative 2 less than or equal to x. Now for the interval notation. So this is a correct answer in an inequality format, but I need the interval notation. For us, the interval notation is typically easier when I see this x on the left side, because it's x less than or x greater than is telling me which way to go. If my x ends up on the right side, such as this, well, we can move it back to the left. I'd have x and then negative 2, and then this is going to be greater than. Now, I didn't really change anything because it's opening to the x, so it's opening to the x. I still have it pointing to the negative 2. It's pointing to the negative 2. So it's just one final step at the end to get that flipped around. And now I would have negative 2 to infinity, bracket on the negative 2, because I see the equal to, greater than, again, number line. If it helps you, negative 2, bracket says greater than, pointing that way. So if I need that variable on the left, I can switch it. It really does look like we changed everything, but we did not. It's opening once again to the x, and it's opening to the x. Or you can think of it as it's pointing to the number. It's pointing to the number. I did not change the answer. I just rewrote it in a different form. Another thing that kind of gets us. Let's go with 7x minus 1 is greater than 9x plus 2. Well, we get our x's together. So this looks pretty similar to number 2 here. We're going to have to bring that 9x over. So typically we usually put the x's on the left. So if I subtract the 9x, negative 2x minus 1 greater than 2. Here's my two-step equation. I'm going to add that 1. Negative 2x greater than 3. And then my last step, divide by the negative 2. And here's the other part. It's a little different than solving equations. This would become x less than negative 3/2. Less than. So when we multiply or divide by a negative, multiply or divide by a negative, flip the inequality. Now, typically, if this happens, it is usually in that final step where I have right here, a negative 2x is greater than 3. So I've got to get rid of that negative 2, divide that out. I did actually divide by a negative, and that's what's going to flip this from greater than to less than. So don't think of it, hey, because I see a negative, if I end up having to divide by a negative, that's when I'll take care of it. So my interval notation in this case, negative infinity to negative 3 halves. We see that less than piece. Right. The other parts back on equation solving that we had, kind of give you another example here, just different look, would be when we had a fraction. So if I had something like this, let's go negative 3x plus 7 over 5 is less than or equal to 2. The key is I've got a fraction there. So when we had fractions in the past, what we wanted to do was get rid of the fraction by eliminating the denominator. So what we did in the past was we multiplied both sides by 5. And so what happened? The 5's canceled on the left. And I'd have 2 times 5 over there. So negative 3x plus 7 less than or equal to 10. 2 times 5 is 10. Now the fraction's gone. We're back to our normal solving process. I'll subtract that 7. Negative 3x less than or equal to 3. Final step, I got to get x alone, so I'm going to divide by negative 3. And since I divided by a negative, this is another one of those cases where it's going to flip the inequality. So I divided by a negative. Instead of less than or equal to, now greater than or equal to. And then 3 divided by negative 3 is negative 1. So this is now my solution. But my solution will be written in interval notation. Negative 1 to infinity. Bracket on the negative 1 because I see the equal to. Again, anytime you're a little bit confused as far as making the transition from this inequality to the interval notation, take 2 seconds to just draw the number line. X greater than, so it's pointing that way. Negative 1, there's my bracket because I see the equal to, and that's going to transition to this.